everyone. So this video is going to help you with the introductory lesson that is talking about greatest common factor, or GCF, and least common multiple, LCM. This video we're going to be talking about GCF, or greatest common factor, and go through a couple examples to help you with the independent practice on that. So to remind you, right, a factor is any number that's being used in multiplication to get to another number, or a number that is evenly divided into another number. So for example, 2 is a factor of 4 because you can multiply 2 times 2 to get 4. And 4 is a factor of 8 because you can multiply 2 times 4 to get 8. So a factor is a number that can be used in multiplication to get another number. So if we wanted to find a greatest common factor in between two numbers, that means we are trying to find the factor that evenly goes into two numbers that is the greatest one in common, right? Because if this was greatest means largest, right? We want the largest number that is a factor, a common factor of two different numbers, or a set of numbers. So this part of the independent practice, it gives you two numbers and it has you compare them and find the GCF of only two numbers. Sometimes you'll have 3 numbers, 4 numbers, whatever, but it's going to be the same process of how we go about solving that. So the way you find the greatest common factor is you actually break it down into its smallest prime factors, and then whatever prime factors are in common, you multiply all of those together, and then that's going to give you the greatest common factor. And I'll show you what that means with this example. So remember when we were doing radical expressions, we were doing prime factorization, where we found basically just all the prime factors, or all of the smallest numbers that multiply to get the number that was inside the radical. That's what we're going to be doing now. So I want you, for this independent practice, to have your calculators handy and get in the swing of using the calculator to find all of the factors. So we're going to break down 16xy squared into its factors right now. And so I'm going to, again, you can follow along with me by using your calculator. So the first factor that would go into 16 would be, you can even do the factor tree. So we can rewrite this. So we have, again, we're comparing 16xy squared and 30xy. But we can do our factor tree, and we know that, remember, prime means that no other number goes into it, right? It's only divisible. You can only divide that number by 1 and itself. So we know that 2 is our smallest prime factor. So always, when you have a number that you're trying to find the prime factorization of, you can always try dividing it by 2. And if it doesn't divide by 2, you could try dividing it by 3. If it doesn't divide by 3, go up to 5. So you can increase the prime factors. And remember, so it'd be like 2, 3, 5, 7, and so on, 11, and so on. So you can also Google prime factors, a list of them, and so whenever you are picking numbers to divide, you can just go up the list of prime factors. And then once you start getting into like the 20s, you know, you can probably say that the number you have in front of you is prime, if you can't find any other factors that go into it. So anyway, so we have 16, and we know that 2 is the smallest prime factor. So if you plugged in your calculator, 16 divided by 2, you would end up getting 2 and 8. Sorry, these markers are acting weird. Okay, so 2 and 8 And so 2 is prime factor, so we're done with that one. So now 8, you can divide by 2 again. What's 8 divided by 2? In your calculator, you would get 4 as the other factor. And then 4 divided by 2 is 2. And so 2 and 2. So now we're left with 2 times 2 times 2 times 2, and x and a y squared. So we can now write this out just all together in one line. So we have many 2's, right? We have 4 2's. Okay. Times an x. And then we have 2 y's. Remember, the exponent is just saying how many times that's being multiplied. So because we have an exponent of 2, we know we have to multiply 2 y's. Okay, so now we broke up the prime factorization of 16xy squared. So these are all of the factors, not the greatest common factor. These are just all of the factors. So now let's go through and do the prime factorization of our 30xy. So 30, again, divided by 2. What's the other number? You would get 15. So now we're done on that side, so now we have to break up 15. If you use your calculator, you would know that 15 divided by 2 is not a whole number, so try again. The next one would be 3. You would get 15 divided by 3 is 5. And 5 is a prime factor, so we're actually done factoring our 30. And then we would just have the x, y. So we have 1, 2. And that's it. And then we have a 3, and then a 5, and then we have our x, and we only have one y this time, okay? Okay, so now to find the greatest common factor, these are all factors, right? If we want to say what's the lowest factor, we could say, well, 2, right? That's the smallest number and it's common. But now we're doing the opposite. We want to know the greatest common factor. So the way we figure this out is we say, well, what are all of the common factors in general? And then let's just multiply all those together, and that's going to be our biggest one. So all of our common factors would be 1, 2, 1x, and 1y. So then when we're all done with that, we would say our final answer, our GCF, is 2 times x times y, or 2xy. Okay, so let's do another example. So now for this example, we have 5ab and 20b. And again, we're trying to find the greatest common factor. So what we're going to do is break it all up into its prime factors, and then find the common ones and multiply. So for 5ab, this is actually easy. It's already broken up into its prime factors. We have, right, because it's 5 times a times b. You can't break that down because 5 is already prime, a, single b, okay? So we can go ahead and write that. And I'm leaving a space, and you'll see why in a second. Okay, so 5 times a times b. Okay? And so now for 20, 20 is not prime. We do have to factor that one. So again, prime factorization, You can pick your 2 as your smallest prime factor and divide. So what's 20 divided by 2? In your calculator, you should get 10 as the other number. And then 10 divided by 2, you should get 5 as the other number. So that's it. You're done with, you're left with only prime factors. So now we have 2 times 2, right? Because these are all being multiplied, okay? Whenever you're doing prime factorization, because we did division every time in the calculator, the opposite of division, multiplication. So we're multiplying all of these back together. So 2 times 2 times 5. Okay? And there's no A, just a B. Okay? And just like the last one, we circle all of our common factors and then we multiply them in the end. So our common factors in this case, we have a 5 on top and a 5 on bottom, so a 5. There's no A in this one, but there is a B, so there's 5B in common, so that is your answer, is 5B. Now for our last example, we have 3RS and 40R squared, and we're trying to find the greatest common factor. So lucky for us again, 3RS, there's actually no way we can break this up. So that's basically, it is what it is. We have a 3 times, and I'm going to leave a big space, times an R times an S. Oops, sorry, my marker. Okay, so 3RS, and the reason I'm leaving these big spaces is so it's going to be easier for us to circle our pairs. That's the only reason why I'm doing that. But you can think of it all in one line, 3RS, okay? Can't break that up, but 40 is not prime, and R squared, there's actually factors there, so we can break that up. So let's go ahead and do that. So again, doing our little trick with our calculator, 40 divided by 2, you get 20 on this side, right? And then you go ahead and do 20 divided by 2, we get 10. Go ahead and do 10 divided by 2, and you get 5, and you're done there. Those are all prime factors. So then when we go to write this out, and then remember, R is actually R times R. R squared is actually R times R. So when we go to write this out of all of its smallest factors, R is actually one factor. So there's actually 2 factors in R squared. That's why it's an exponent of 2. So let's write all of the factors out. We have 3 2's, 1 5, which will be purple. I don't know if you'd be able, if you guys can tell the difference between purple and blue. I think you could tell. And then 2 R's. No S's. Okay, so now let's go through and look what factors are the same. There's a 3 up here, but there's no 3 down here. There's 2's down here, but none up here. There's a 5 down here, but no 5's up here. There's R, but there's 2 R's down here, but only 1 R up here. So there's only 1 R in common, and then an S, and there's no S down here. So there's literally, this is the answer. There's only 1 R in common, so your answer is R. Okay, so I hope this was not too hard, right? Because it's just prime factorization, and then finding the common factors, multiplying them together to get your greatest common factor. But of course, if you have any questions, please stop by office hours. We'd love to help out.